What we'll see here in worksheet 6.2 here is we're going to see a shift in the type of equation we're looking at. We're no longer looking at h and k. A value sort of is still related at some point to some degree, but to find the roots, it's not necessarily as we're not necessarily as concerned with the vertex, although that'll be part of it. So to find the roots, we need to understand that there's going to be a point on the x-axis, or if we're finding roots, which are points on the x-axis, we're going to need to plug in 0 for y, because you'll notice that y has already got zeros here. So if we know that it's an x-intercept, then y is going to be 0, and therefore if we plug in 0 here, all we need to do is rewrite this in a way that we can see those roots. We've done this a little bit before, but we're really making it a formalized. To find the roots, you factor the equation. That's the bottom line. Okay, and when you think diamond, or when you think whatever you do to factor, you got two numbers that multiply to get 3, but add together to get 4. And that's a 3 and a 1. Okay, so if we're factoring this to get that, and we now have a 0 equals this, we have something called the zero product property that states if you have two products that equal 0, then both of those products individually could potentially equal 0. X plus 3 equals 0, and x plus 1 equals 0. Subtract 3 from both sides, you get x equals negative 3. You subtract 1 from both sides, you get x equals negative 1. Now, negative 1 here, negative 3 there, those are two intercepts. Now, contrary to what we did when we saw a vertex and built around it, we have intercepts that we were going to have to look between. Okay, directly in between those we have a vertex. Okay, and based on the stair steps that we've kind of worked with up to this point, a pattern of up 1 over 1, up 1, up 3 over 1, and so on. If you've got a vertex that lies directly in between those two, there's a couple different ways you can approach it. First of all, you know the x value of the vertex is going to be right in between. So if you've got a negative 1 here and a negative 3 there, and there's only one space in between it, the middle has to be a negative 2. And if this is a 0 and that's a negative 4, I kind of did that backwards, oops, but that's okay. Then you've got 2 points outside that, you've got the negative 2 inside. Now, that negative 2, you could either plug it in, or you can go with your stair step. Okay, the coefficient out in front, the a value is still 1. So that means our stair step from the vertex up to these 2 points is only going to be 1, or you can just say step down 1 below it. Now, if you're not comfortable with the stair step, plug it in. And you have two options to plug it in. Plug in, oh, by the way, there's a 0 here and a 0 there. If I plug in a negative 2 here, negative 2 squared is 4. 2 times, or negative 2 times 4 is negative 8. So I've got 4 minus 8 plus 3. 4 minus 8 is negative 4, plus 3 is a negative 1. There's that negative 1, but there's that point, negative 2, negative 1. Here's an even better option. Take that negative 2 and plug it into the factored form. You needed a factor to get these anyway. When you plug it in here, you have a negative 2 plus 3 is a 1. Negative 2 plus 1 is a negative 1. 1 times negative 1 is going to give you that same negative 1 here. Okay. Once you get that, you might see, oh yeah, it's up 1 over 1, then it's up 1, 2, 3, and over 1. Or various other options here. Let me show you one other trick. We won't take as much time on each problem, but I think it's an important foundation to be laid here. That right there, same position as the y-intercept in an equation of a line, that is also the y-intercept of our parabola. And so if you're given an equation in this form, you can factor it to get your roots, but you can also see the y-intercept from the beginning. So there's my y-intercept, and because there's synergy involved, both of these guys are going to have the same y value, so it's 3 here and 3 there, bada bing, bada boom.